Okay, so characteristics of ionic bonds. So far, we have talked about how ionic bonds are made, and we've shown that in our practice, our examples, and we just did it on our quiz. Once those bonds are made, though, we have an ionically bonded substance. And we want to know what are the characteristics of these ionic substances. Well, first of all, ionically bonded substances are very strongly bonded. So they have a strong bond. Ionic bonds are very, very tough, very strong, very difficult to break. They are what we refer to as crystalline solids. So if you think about what a crystal looks like, most of us can think about what, we're familiar with a crystal object, something that's crystal. Ionically bonded substances are crystalline solids. They look like crystals when they're bonded together. They have very high melting points and very high boiling points, and we're going to talk about why that is. And ionically bonded substances are good conductors of electricity, but only if you dissolve them in water first. So if you dissolve your substance, it will conduct electricity really well. All right. So let's discuss not just what these characteristics are, which you need to know those, but why are they the way that they are? Why are ionically bonded atoms or compounds strong? Well, it has to do with the structure. When things are ionically bonded, we don't just have like one sodium ion bonding to one chlorine ion. There's many cations bonded to many anions. Hundreds, or if not thousands, of these ions are bonded to each other. So this is a really, really stable and strong structure, and we call it a crystal lattice. And it kind of looks something like that. This is like a small portion. It'd be like a snapshot of just a part of a crystal lattice structure. All right, so we have lots of cations bonded to lots of anions. Between every one of those yellow and green dots there, the yellow represents the cations, the green represents the anions. There is a bond taking place. In order to break a bond, you have to apply energy. So let's say we were going to karate chop these bonds. Would it take you a lot of energy to break all the bonds in that structure? Think about it. If you had to karate chop every one of those lines, is that going to take you energy or not? Yeah. What if there were only one line there? Which takes more energy, that or something with one line? That definitely. So, because of the way that they're connected to each other, they're extremely strong. And it takes a lot of energy in order to disrupt that process. This is a very stable structure. If I told you, if I gave you some toothpicks and marshmallows and told you to build me a platform, most of you would probably build something similar to this. It is going to give you a lot of support and structure for whatever it is that we're making. So the crystal lattice structure. The next slide, there's nothing to write on. I just wanted to show you some crystalline solids at room temperature. This is beryl. You can clean this up if you give it to a jeweler and that becomes a ruby. Sodium chloride. This is table salt under a microscope. Looks like diamonds. But it's a crystal. It's a solid. Fluorite. This is another crystalline solid. This is what we make an amethyst. A jeweler would, what we refer to as an amethyst, a purple jewelry. But so our ionically bonded substances have a very strong crystal lattice structure and they form crystal solids at room temperature. They also have high melting and high boiling points. It takes a lot of energy to break all the bonds in that crystal lattice. In order to melt something or boil it, you have to break the bonds. And if you break the bonds, then it's able to change state, which makes it go from a solid to a liquid or a gas, depending on which direction you're going in. So if I'm trying to melt something, in order to get it to melt, I have to apply enough energy to break all the bonds in it for it to melt from its solid phase to its liquid phase. Ionically bonded compounds have high melting, all right, so very strong because of the crystal lattice structure, has a high melting point and a high boiling point. Finally, the last characteristics is we said it's a good conductor of electricity, but only if you dissolve it in water. Once you take an ionically bonded compound and you dissolve it in water, we form an electrolyte solution. And this is where we have our liquid water or whatever our solvent is, but usually water. And then inside of it are our cations, which are positive, and our anions, which are negative. So let's think about electrolytes. All right, let's think first, and I'm going to kind of guide you through this. First of all, a car battery, or just any battery for that end. What is present on every battery? What do they have on each end? Think about the ones. A positive side and a negative side. It is absolutely essential to conduct electric current that you have a positive and a negative. Okay. The electric current cannot take place unless positives and negatives. If you had to jump off a car, if your car battery was dead, if you open that up, you look at the battery, there's positive and negative post. You would connect your jumper cables in a way that will provide, that connection there. But you have to have positives and negatives to conduct electricity. An electrolyte is a substance that conducts electricity. Okay. And it is because, let's say this was salt. If I took salt and put it in water, it will dissolve. And when it dissolves, I end up with little sodium ions, which are positive, and my chlorine ions, which are negative. Now let's think about where we've heard the term electrolyte. Where you hear electrolyte at? Drinks. That's right. Gatorade, Powerades, energy drink, sports drinks. Those are all electrolyte substances. What is the part? Okay, so let's say you've been at, I don't know, football practice and it's a hot summer day. Why do you need to drink Gatorade?
To stay hydrated.
Why you need to stay hydrated? Why you need that? Well, what happens if you burn it all up?
You lose energy.
You die.
So what?
You die.
I've never seen anyone smile the way you just did. while
Keep it
saying
creepy.
die.
You gotta meet my children. All right. So let's think about it. You're an athlete and you've been sweating. I don't care if you're an athlete. Let's say you're just cleaning the yard, whatever. You've been sweating quite a lot. What does sweat taste like? Salt. There is a reason that your body has to have electrolytes. How is my brain telling my finger to do this movement? How's my brain communicating that?
Nerve system.
My nervous system. You are passing messages from your brain to my hand, whatever I'm moving here, using an electric impulse. If all the messages in my body are traveling through electrical impulses, then I need electrolyte substance to make that message. What happens when you hear the tragic stories of a 16-year-old football player that drops dead in a July practice? It is usually from dehydration. And what happens? Your brain communicates with your heart and your lungs and your organs. All of those things are communicated with through the nervous system. You have to have electrolytes in your body in order to conduct the nervous impulses that tell your heart to beat and your lungs to move. So what happens when you get severely dehydrated is you don't have those electrolytes, and then therefore you don't have those pathways. And that's how organs stop working, because your brain can't communicate for them. The autonomic nervous system doesn't work anymore because we can't communicate. So electrolytes, these are things that conduct electricity. We generally drink Gatorades and things like that when we have been doing athletic events because we want to replace the electrolytes that we've sweated out. If you're really sick, if you've been throwing up for a long time or whatever, and you go to the hospital, number one thing that they check when you walk into the emergency room is your electrolyte panel. And if it's really out of whack or low, they can actually give you IV fluids in order to stabilize it. And you feel way better as soon as that happens. So to recap, ionically bonded substances. They are strong bonds because of the crystal lattice, because there's hundreds of cations bonded to hundreds of anions. They're going to have very high melting and boiling points because you have to break all the bonds in the crystal lattice. If you dissolve these in water, they become electrolytes, which makes them good conductors of heat and electricity because we have positives and negatives where an electric current can travel from one side to the other. You can weaken bonds, yeah. But you have to apply energy to make that happen. Generally, we apply energy in the form of heat. Not always. The heat's the go-to. And once you finish that, that is all of chapter 7, section 2. That's it. We finished with chapter 7, section 2.